All right, integrated math 3. This is your lesson. We're starting a new unit. It's called trigonometry. We're going to be doing this unit between the Thanksgiving break and the Christmas winter break. And this is the first lesson on that. This was assigned to period 1 on Monday to period 3 on Tuesday. I'll be a little flexible on this due date since I'm getting these solutions, these answers up kind of late, but try to get it done by Friday because you need to do this to do the next lesson, which is assigned this week also. Okay, so what are we talking about here with trigonometry? If you go back to your basic geometry, and you draw a triangle like this, and a principle of geometry called the Pythagorean Theorem says if you know two of the sides and it's a right triangle, so that's what this little box symbolizes, is it's a 90-degree angle. If you know two of the sides, you can figure out the third. So let's say this side is 4 and this side is 3. There's a formula, but the Pythagorean Theorem says that a squared plus b squared equals c squared. And you will need this formula, by the way, in this assignment. So which side is A, B, and C? A and B, it doesn't matter. Let's start with C. It does matter that C has to be the longest side, which is called the hypotenuse. We'll get into that name in a minute. So this side must be C. As for the other two sides, it doesn't matter which one you call A and which one you call B. So we can call this one A, and this side will be B. So if we plug in the numbers, we have 4 squared plus 3 squared, and that's going to equal c squared. Well, 4 squared is 16, 3 squared is 9, 16 plus 9 is 25. So that means 25 is c squared. So if I want to know what c is, c squared is 25. I take the square root of both sides, and that gives me c equals 5. So this side over here would equal 5. You could also work backwards. If I had been given this side and this side, I could have subtracted this side squared from this side squared and gotten this side squared and figured out eventually that that was 3. So Pythagorean Theorem says in a right triangle, if you know any two of the sides, you can figure out the third side. Trigonometry takes that a step further. It says if you know any one of the sides, assuming again it's a right triangle, if you know any one of the sides and the angle, one of the angles other than the 90-degree angle, in addition to the 90-degree angle, you can figure out not only all of the sides, but you can figure out all of the angles inside as well. Now you're going to have this in front of you. And if you need to, stop the video and copy this if you don't have a way to print this out. But you really need to have this whole table in front of you. It's a reference table. It's not a problem. And what I'm going to introduce you to is some concepts here in trigonometry that are really fundamental. By the way, I will say this. I've mentioned to you in the past that I've worked in math all my life in various fields, in either engineering or accounting. And a lot of times when we're doing math that I say, we never really use that in the real world. Like rational expressions and things, I would tell you that this isn't really practical. It's good at developing your math skills, but it may not have a lot of practical applications. But I'm going to tell you, trigonometry, if you go into any field of science or engineering that uses math in a scientific context, you're going to use this all the time. So, and if you go into calculus, for example, you're going to need to have this. So this is a subject that does have some real-world applications, particularly these first 3. And these are the 3 we'll talk about the most, are sine, cosine, and tangent. These kind of are derived from sine, cosine, and tangent, so we'll talk about those. So first thing you have to do is you have to label the sides, give names to the sides of the triangle. So if this is the angle we're dealing with, this is the angle that we know other than the 90-degree angle, then the side that's the longest, just as it was up here with the Pythagorean Theorem, is called the hypotenuse. Now the side that's on the opposite side of the triangle from this angle is called the opposite. Now if this had been our reference angle, it could have been. If this had been our reference angle, the opposite would have been this side over here. Okay, but in this case, with this as a reference, you can just basically draw a line across like that. That side's going to be opposite. And then the other side, I just call it the other guy, is adjacent. The word adjacent means next to something. When you ride the trolley, they might tell you that a trolley going to a certain location is going to come by on the adjacent track. It means the track next to the one that you just got off on. All right, so the adjacent angle is the angle that's next to the adjacent side, rather, is the side that's next to the angle that we're interested in here. The hypotenuse is also adjacent to it, but it already has a name. So hypotenuse and adjacent, and then the opposite is on the other side. So here's the relationship for this specific angle. For the sine, it's pronounced sine, that's the word, that's the abbreviation, but you still say sine, not sin. So the sine of this angle is equal to the opposite over the hypotenuse. So it's like a fraction. You make a ratio of this side over this side, and that's called the sine. The cosine, abbreviated COS, is the adjacent over the hypotenuse. Adjacent over hypotenuse. This side over this side. Just like a fraction. Just make a ratio of those, of the lengths of those two sides. And finally, the tangent is the opposite over the adjacent. And that's going to be a ratio of this side over this side, and that's called the tangent. Opposite over adjacent. Now these are some that we will use. In fact, in this assignment we'll use some of these, but they're not really spoken of quite as frequently. The cosecant is simply the reciprocal of the sine. Notice that sine is opposite over hypotenuse. If you take the reciprocal of that, you flip it over, you get hypotenuse over opposite. That's what the cosecant is. The secant does the same thing with cosine. Cosine is adjacent over hypotenuse. The secant is hypotenuse over adjacent. And finally, the cotangent does the same thing with the tangent. Tangent is opposite over adjacent, and cotangent is adjacent over opposite. So those are some that you'll learn just with use. It always seemed a little backwards to me that the cosecant goes with the sine. It doesn't go with the cosine, it goes with the sine. So the cosecant is the reciprocal of the sine, and the secant is the reciprocal of the cosine. That's the only one that's a little hard to remember sometimes. All right, so we're going to use these relationships to do this assignment. And let's go ahead and get started. You'll find that once you get the hang of this, it's not really all that hard. Okay, so go back and copy down that table and the triangle so you have a reference of which sides are which. So what I want you to do whenever you solve one of these problems is always label the sides first, opposite, adjacent, hypotenuse, okay? So here's the reference angle. So the longest side is this. It doesn't necessarily, the longest side could be on this side, it could be on this side, it could be on the bottom. It's not on one particular side, it's which one is the longest, okay? So in this case, it's over here. So this is the hypotenuse. Go ahead and label that one first, whichever one is the longest. Then there's your reference angle. Just draw a line, a light line straight across to there. That's the opposite. And finally, the other guy is the adjacent. There you go. So always do that. I want you to do that on every problem that you do. So what it wants to know is what's the tangent of theta. So if we go back to our sheet, we see that tangent is opposite over adjacent right there, okay? Okay, so it's this one over this one. The problem is we don't know this one. Okay, so how do we find it? Well, you can go back to the olden days of the Pythagorean Theorem. You know two sides, that means you can figure out the third. So let's just go ahead and assign names to these. The hypotenuse is always C. We'll call the opposite B, and we'll call the adjacent A. And so we're just going to use the Pythagorean Theorem, a squared plus b squared equals c squared. Okay, so we don't know A, so that's a squared. We do know B, it's 12, so that's going to be 12 squared equals C is 13 squared. Okay. So that gives me A squared plus, you can do this on your calculator, 144 equals 169. And now you're just going to subtract 144 from both sides. And you get A squared equals 25. Take the square root of both sides, and you get A equals 5. So this side over here is 5. Okay, so we have 5 for this side, we have 12 for this side, and 13. So what is the tangent? We just showed you it's opposite over adjacent. That means it's going to be 12 over 5. So the tangent of theta, our unknown angle theta, equals opposite over adjacent, which is 12 over 5. You do not put that in decimal form, and you do not convert it into a mixed fraction. A mixed fraction would be 2 2/5. You leave it as an improper fraction, 12 over 5. Okay, and that's the answer to that one. All right, so let's keep going. Now we didn't need if you don't have a calculator, you're going to need one that has a sine, cosine, and tangent function on it. So let me show you one of those right now. Okay, so if you go to Google and go to online calculator, let's do this here. All right, and there you see online calculator, full screen online calculator. Go ahead and click on that. And it gives you a little simple 4-function calculator, but that's not going to be good enough for what we need to do. So you're going to come down here, and right in the top center there, it says Scientific Calculator. That's the one you're going to need. Just go ahead and click on that, and that will bring this up. And you only need to know, other than using normal calculator functions, you're going to need to know these 4. There's sine, cosine, and tangent. Now, right now we're talking about degrees. You've been introduced to degrees in the past. There's 360 degrees when you go around a circle, but there's another measure that's new to you. It's called radians, and if you click on degrees, it'll change it to rad. That's radians. We'll talk about what that is in 5.02, lesson 5.02, what a radian is. Right now I'm going to click it back to degrees. That's all we're going to be using in this lesson. The other thing we talked about before in another context was inverse functions. An inverse function is a function that reverses a function. So addition and subtraction are inverses of each other. Multiplication, division are inverses of each other. They reverse each other. Well, the inverse function of sine, cosine, and tangent is inverse sine, inverse cosine, and inverse tangent. And the way you get to that down here is this button in the lower left says first. You click on it, and now it says second. The buttons turn to a dark green. And sine minus 1 doesn't mean sine raised to the negative first power. It means inverse sine. This is inverse cosine and inverse tangent. All right, so we'll show you how to use those when we need them. But you can just have this calculator on a background tab while you're working on this assignment. Okay. All right, let's keep going here. We're going to move down to the next problem, number 2. And I'm going to do pretty much most, if not all, the problems on this assignment. So they want you to identify the cosine of theta. Okay, so again, first thing is do this on every single problem, is label the sides. The long one is the hypotenuse. The one that's across the triangle from this angle is called the opposite. And the other guy is the adjacent. All right, so cosine, you have to, what is cosine? You come over here. Cosine is adjacent over hypotenuse right here. Okay. So we're going to write that cosine of theta. I always want you to also write the general formula that I just pointed to. In that way, that you end up committing them to memory. So cosine is adjacent. Okay, and in this case, that would equal 5 over 13. That's the cosine of theta. Okay, so cosine theta equals 5 over 13. Now I'm going to show you something that the problem didn't ask you for here. What if I wanted to know what this angle theta is? And I want to know in degrees what's this angle theta? Then what you would do then is you would say theta, that's the angle, equals the inverse cosine. This is where you would use an inverse cosine of this ratio here, 5 over 13. There's an alternate way to write inverses, by the way, besides the -1, and that is this. It's called arc cosine. So you may see different books use that notation, but it's the same exact thing. It's just a different way of saying inverse. So why don't we do this? Let's go to our online calculator here, and we're going to take the arc cosine, or the inverse cosine of 5/13. So I pull this up, okay, and the way this calculator works, the way this calculator works is you put the number in first. So I'm going to put in 5 divided by 13 equals that number. Now I'm going to come here and do the cosine -1 right here where you see I'm circling, and I'm going to hit that, and that gives a number of 67.38. We'll call it 67.4. So that means theta equals 67.4 degrees. So that's right here, 67.4 degrees. It didn't ask you to do that, but later problems will, so I just wanted to show you that function right now. And there we go. That's what I had just written down, and that's where that angle would go. Now, you can also figure out this angle up here. What's this angle? Well, the corners, the angles of a triangle must add up to 180 degrees. So that means this question mark angle plus 90 degrees, because we have a 90-degree angle there, plus 67.4, the one we just figured out, equals 180 degrees. Or another way you could have said it is 180 minus 90 minus 67.4. And that equals 22.6 degrees. So this angle right here is 22.6 degrees. That angle right there. Didn't ask you for that, didn't ask you for this, but I'm showing you how to do it because you will need to know to do that later on. All right, let's move on to our next problem. Okay, this problem is asking you to find this measure right here, x. So again, start by labeling the sides. The longest side is this one, that's the hypotenuse. Here's the angle, so if you go across, that's the opposite. And the side that's next to the angle, but not the hypotenuse, is the adjacent. Okay, so what you want to do is find the side that you're trying to figure out and the side that gives you a piece of information that you know. So we know this side, this is the side we're trying to figure out, the opposite, and the side that gives us a piece of information we know is the hypotenuse. So opposite and hypotenuse. So which of the three functions, sine, cosine, or tangent, relates opposite and hypotenuse? So we come over here and right here, and there it is. It's the sine. The sine is the one that relates the opposite and the hypotenuse. Okay, so we go ahead and write that out. The sine of theta is the opposite over the hypotenuse. Right there. Now we can fill in what we know. We know theta. This time we were given an angle, and that's theta, so that's 30 degrees. So we're going to write sine of 30 degrees, usually put it in parentheses, although you don't have to, equals the opposite. That's what we're trying to find out here. In which, or you could have put x also, that's the variable, that's the unknown, over the hypotenuse, which is 12. Okay, so that's how you set it up. Now you're going to go back to the online calculator and you're going to find out what the sine of 30 is. So I go back there. Now be careful. It's set right now for the second function. See what I'm circling down at the bottom? So I'm going to click on that. I want to go back to the first. I don't want to know the inverse sine. I want to know the sine. So here's sine right there. I'm going to, now what you need on this calculator is to first put in your number. So I'm going to clear what I had there before. And it's 30 degrees. Since it's set right here for degrees, right there in the upper left-hand corner, it knows that that means degrees. Now I'm going to click on sine, and you get 0.5. Okay, and that equals opposite over 12. So that 0.5 sine 30 is 0.5 equals opposite over 12. Now I'm going to multiply, it's just an algebra problem now. Multiply both sides by 12. Cancels there. So the opposite, which is x, what we're looking for, equals 12 times 0.5 is a half. That's going to be 6. So this side equals 6 right there. And that's the answer to the problem. Okay? Not that hard. Now what you could also figure out if you wanted to is what this side is. You could either use trigonometry or the Pythagorean Theorem. This angle right here, 30 plus 90 plus this angle equals 180. So this angle would have to be 60. So you can figure out all of the angles and all of the sides using trigonometry. Okay, let's keep going. Okay, very similar type of problem. First, identify the sides. The longest side is this one. That's the hypotenuse. Here's the angle we're referencing. So you go across the triangle to there. That's the opposite. And this over here is the adjacent. All right, so we're trying to find something that's on the hypotenuse, and we're given a number on the adjacent. So hypotenuse, adjacent. We come over here, we find which function relates those two, and we come down here, and there it is, adjacent and hypotenuse. That would be the cosine. So this is a cosine operation. So cosine of theta equals adjacent over hypotenuse. All right, so now we can fill in the numbers. The theta, the angle, theta is the angle, is cosine. And adjacent we know is 12. And our unknown is the hypotenuse here. Again, you could put x, or I'm just going to put hypotenuse there. All right, so now go to the online calculator and find what the cosine of 59.3 is. So clear, put 59.3. Let me clear that again. 59.3. And now you go to cosine, this one right here. Click on that, and it gives you 0.51. We'll just leave it at 0.51. So we come back, and this cosine 59 is 0.51 equals 12 over hypotenuse. Now we got to solve for hypotenuse. It's just an algebra problem. So it's height on the top there and height on the top there. Cancel these two. Okay, and so now you have this. All right, so we're going to divide both sides by this. Cancel that, and you have hypotenuse equals 12 over 0.51. And when you do that on your calculator, you get right around 23.5. So that's this side right here is 23.5. Okay, and that's how you do that. Let me be sure you can see the whole thing. So there's the entire answer. All right, let's move on to number 5. Okay, find the measure of the angle. Whenever they ask you to do that, you're going to have to use the inverse function that I showed you back a little bit earlier. So again, first thing, they'll always start off labeling the sides. so we need to find this. The thing we know are these two sides, which is adjacent and hypotenuse. So again, go over here, and adjacent and hypotenuse are right there. And that's going to be a cosine function. So the way you write that is, the cosine of this angle is the adjacent over the hypotenuse. So you write it like this. First of all, write the general function adjacent over hypotenuse. Do that first. Okay, now the cosine of theta, we still don't know what theta is, so we just still have to write theta, is 11 over 15.2. All right. So theta, we take the inverse, theta equals cosine minus 1, again that means inverse cosine of this. Okay. All right, so now we go to our calculator, online calculator. Let's clear it. We have to go to the second function down here. It says first we need to go to second because we need an inverse cosine. And the numbers that we're going to put in are 11 divided by, click the divided by sign, 15.2, and I hit equals, gives you that. And now you come up here where it says cosine minus 1, where the arrow's going around there, and you click on that. And it gives you 43.6. So theta equals 43.6 degrees. Get back on the screen here. Theta equals 43.6 degrees, so that's what this angle is right here. 43.6 degrees. And again, if I took 180 minus 43.6 minus 90, it would tell me what this angle is. But it didn't, so we're not going to do that, okay? And you could also figure out what the opposite is using either trigonometry or the Pythagorean theorem. Okay? All right, let's move on. Similar problem right here. Let's go ahead and do this one. So hypotenuse is the long side. The opposite side is this one over here. That's the op. And the adjacent side is here. You may find it easier to say this is hypotenuse, the other side of the angle is the adjacent, and so this side must be the opposite. Whatever helps you to remember it the best, okay? So what they want to know is the angle. So what do we know? We know the opposite side and we know the hypotenuse. So we come over here and the function that relates opposite and hypotenuse, there it is right there, is sine. And again, write the general equation, it's opposite over hypotenuse. So now we're going to come here and write sine of theta, which is what we're trying to find, is 8 over 15. So to find theta, theta is going to equal the inverse sine of 8 over 15. Okay, and that is going to be, theta is going to equal, we'll go back to our calculator, clear it, do 8 divided by 15, and then hit inverse sine right here. Oops, I did something wrong. Don't know what I did wrong. Let's try that again. 8 divided by 15. Oh, I didn't hit equal. Sorry. There you go. Equal. There you go. That's not right. Let's try that again. I'm going to use my keyboard. I don't like using this. 8 divided by 15 equals that. Okay, there you go. That's better. That's 8 divided by 15. So it's a decimal number. Now you're going to hit inverse sine over here, right there, and you get 32.2. So we'll go on back to our sheet. Theta equals 32.2 degrees. Right there. 32.2 degrees. Okay? And that's that. That's all they're asking for. All right, let's keep going. All right, number 7, it says find the value of the trig function. So they're looking for the cotangent if you know the secant. All right, so now we're getting into some of those other functions. So let's come on down here. So there's cotangent, and there's what a cotangent is. Whoops, sorry, wrong screen. There's what a cotangent is. It's the reciprocal of a tangent, and they're giving us the secant. So let's go ahead and write down what we're looking for and what we want to know. So cotangent is adjacent over opposite. And that's what you're trying to find. So you can just put a little question mark there. Secant, and I really should put theta to be proper. Theta. It's always of an angle. All of these functions are of an angle. Secant, it says, equals 5 over 4 right there. Okay, so what we're going to do is draw a triangle. And this is always the way when I draw my standard triangle. You do it any way you want. I do it with the angle down here in the lower left. That's just the way I'm used to doing it. But it doesn't matter. It matters where the hypotenuse is, where the adjacent is, and where the opposite is. Okay, so I'm going to call this angle theta here. And this is the hypotenuse. And this is the opposite. And this is the adjacent. Okay, so what is it telling us? What is the secant again? The secant is, and I didn't write the formula. That's bad on me. The secant is, the formula is hypotenuse over adjacent. Hypotenuse over adjacent. Because that's what I need to know here. I have to reference that triangle. Okay, and it says in this problem that equals 5 over 4. So what that means is the hypotenuse is going to be 5, and the adjacent here is going to be 4. All right, so I can use the Pythagorean theorem here, or I can't use trigonometry because I don't have enough information. I don't have an angle. But I can use the Pythagorean theorem. So the hypotenuse is C. We'll call this side A, and we'll call this side B. So A squared okay, so A is the side with 4, so 4 squared plus B squared equals 5 squared. So that's going to be 16 plus B squared equals 25. And if you don't mind, I'm going to go back up here because I have space up there. So I'm going to take this up here. So B squared, and I assume I'm not doing too many tricks on you here, subtract 16 from both sides, and that gives you B squared equals 9. Therefore, B, the square root of that, just take square root of that, and B equals 3. So this side right here equals 3. Okay, why did we have to do that? We had to do that because the cotangent is adjacent over opposite. We knew the adjacent, but we didn't know the opposite. So I should have explained that to you first. That's why we had to do this. So now we do know the opposite and the adjacent. So now we can answer this question. So the cotangent is the adjacent over the opposite. So it's 4 over 3. And again, you don't change that to a mixed fraction, 1 1/3. You don't change it to a decimal, 1.333. You leave it like this. That's the way it's done in trigonometry, okay? So that's the cotangent. That's your final answer right there. So let's walk through that one more time. Given secant 5 over 4, and secant is hypotenuse over adjacent, so the hypotenuse is 5 and the adjacent is 4. That's the secant right there, is 5 over 4. They're asking you for the cotangent, which is adjacent over opposite. So it's this over this. Well, we knew these two, we didn't know what the opposite was. So you have to use the Pythagorean theorem to figure out what this side is over here, and we figured out that it's 3. So now we have the opposite and the adjacent, and that's what we need to find out the cotangent, which is adjacent over opposite. So there's adjacent, it's 4, and there's opposite, it's 3. So the cotangent adjacent over opposite is 4 over 3, and that's your final answer. So just the best way to learn this is cover this up right now that it's fresh in your mind. Just get a blank piece of paper, it's not even part of your assignment, and see if you can write that answer out by yourself. If you can't, then do it again and do it again. If you really want to get good at this, that's what you have to do. You have to practice it, just like you have to practice anything to become good at it. Okay, I'm going to keep going to number 8. And it says, find the secant if you're given this sign. If the sine of theta is square root of 2 over 2. So again, I'm going to draw a triangle. Again, the standard way I like to draw it is like this. Okay, it's a right triangle, always. Okay, so the sine of theta we're given. So first of all, let's label our sides. This is hypotenuse. The theta for me is always down there in that corner. That's where I put the theta. So this is the opposite. And this is the adjacent. Okay, so what is sine? Sine is, come back here. Sine is opposite over hypotenuse. Okay, so there's a ratio and there's a ratio. So what that means is that the opposite is the square root of 2 and the hypotenuse is 2. Okay, you just take that ratio and assign it to that. So over here I have the square root of 2 and hypotenuse here is 2. Alright, so again, I don't know the angle, so I can't use trigonometry. I have to use Pythagorean Theorem. So it's a squared plus b squared equals c squared. And we'll call this side A, and we'll call this side over here B. Okay, so there's b squared, and there is c squared. Okay, this side is c. Hypotenuse is always c. Alright, so let's square these. So a squared plus the square root of 2 squared, that's an inverse, right? You take a square root and then you square it again, it gets you back to 2. And then 2 squared is 4. So now I'm going to subtract 2 from both sides. It goes away, and you have a squared equals 2. Now you take the square root of both sides. I'm going to move over here. The square root of a squared equals the square root of 2, so that equals a. Square root of a squared is a, so there it is. So there it is right there. So this side is the square root of 2. So both of these sides are the square root of 2. So I didn't draw this to scale. If they're both the square root of 2, this side should be equal length to this side. It doesn't look like it. Again, I don't know what that triangle is going to look like when I draw it, but it should really look more like this if I came over here and drew it. Okay, where this side and this side are equal. So there's the square root of 2 here. And there's the square root of 2 there. Okay? And then this side is 2. Alright, so we figured out the size. So for secant, what did we need? Secant of theta equals, come over here, it's hypotenuse over adjacent. Well, you know, I didn't even need to do all that. It's hypotenuse over adjacent. Well, yeah, I did, actually. It's hypotenuse over adjacent. It's this over this. Yeah, I did need to do that, actually. So it's hypotenuse over adjacent. So let me write it down here. Secant of theta, which is what they're asking you for, equals hypotenuse is 2 over adjacent is square root of 2. Okay? And that's the answer to that. However, if you remember from learning radicals and roots sometime, You can't leave a radical or a root on the bottom. So how do you get rid of it? And the answer is you multiply top and bottom by the square root of 2. Okay, so 2 times the square root of 2 is 2 times the square root of 2. And the square root of 2 times the square root of 2 is 2. Again, you're taking an inverse. You're taking square root of 2 and you're squaring it right down there. So that's 2. So that's 2. And now what you can do is you can cancel those 2's. So your final answer here is secant of theta equals the square root of 2. And there it is. That's your final answer. Okay? So let's review that problem again. We were given the sine. A sine is an opposite over hypotenuse. So there's the opposite and there's the hypotenuse. They wanted the secant, which is the hypotenuse over the adjacent. So we needed to figure out what the adjacent was. So we were given the opposite and the hypotenuse. We don't know the angle, so we can't use trigonometry. So we used Pythagorean Theorem. We did all that over here, and we figured out that this side A is the square root of 2. It turned out to be the same as this side. Okay, so that's the adjacent. So the secant is going to be the hypotenuse, which is 2, over the adjacent, which is the square root of 2. So I came down here and did that. Hypotenuse over adjacent, and that was secant of theta. Problem is, you're not supposed to leave a square root or any kind of root on the bottom of a fraction. It's just the rules of math. So the way you get rid of it is you multiply top and bottom by square root of 2. So on the top, that gives you 2 times the square root of 2. On the bottom, square root of 2 gives you 2. And that top 2 and that bottom 2 cancel. So your final answer is secant theta equals the square root of 2. Again, if you really want to understand this, okay, just copying it will get you through the assignment, but you should practice it until you can do it without looking at these notes, okay? And if it's still a problem after that, and you still don't get it, then come to tutoring. That's where tutoring comes in. So you do a couple of steps before you come to tutoring, although you can come to tutoring anytime. And that is you work the problem through on the assignment, you try to do it by yourself. If you still don't get it, then that's what tutoring's for. Okay, let's keep going. All right, number 9. I tell you what, I am going to end this video. It's getting a bit long. It's at 45 minutes. So I'm going to do 9 through the end. I think it's 12 on a separate video. And I'm going to go ahead and put this up for you. Okay, so we'll see you on the part 2 video for 5.01.